Now, this recording is for linear inequalities. We have finished the linear equation. Now, this time it is not about equal, but is about unequal, so inequality. Now, here we go. There's inequality symbols, equal and not equal to. So this is a symbol. Less than, for example, -3 is less than 1. Greater, less than, or equal to. Greater than or equal to. All right, so just have a quick review of the inequality symbols. Now, the focus in this section, one of them is this, called the graph of inequalities, or another way to say is the graphical representation of an inequality. Excuse me. Now, what does that mean? Well, we use a number line to represent a number, right? So if this is a 0, and this is 1, and then this is a -1, all right? So if I say a number n equals to 1, now what do I do? Use a number line to represent this statement that this number is 1. So then I would put a solid dot here, and so that means this number is 1. So n equals to 1, and then this representation using the number line, they mean the same thing. Now, how do I use a number line to represent something in an equality? Now, such as this number does not equal to 1. This number is larger than 1. So now what happens here is that we have a number line. Now this is a 0, and this is a 1, and this is -1. Of course, I can keep on going, and this is a 2. So if I say, using this number line to represent a scenario where this number is larger than 1, that means in a range of numbers, those numbers are all larger than 1. So what I do is that it is an empty dot. And then there's a arrow sign go over that way, which means all the numbers on the number line here, which goes to the positive infinity, any number in this range here, they all satisfied this inequality. Now, next one is that, how about n is not only larger than 1, but also equal to 1. Now, in this case, the dot will be a solid dot. Means this includes 1, but any number that is larger than 1. Now, translating inequalities. This is the same as the practice that we did of translating any language into a mathematical language. So this is again, we're translating an English language into a mathematical language. So here we go. There's a word called at most. Now the sentence could say, at most, 3 students will not pass the test. So a mathematical statement, at most, means this number will be, the largest will be equal to 3. And all the other number, as this number, is all smaller than 3. Okay? At least, same thing, at least. Sue is at least 5 years old. So she might be 6, she might be 7, difficult to tell, but at least she's 5 years old. So her age is at least 5, but perhaps, or very likely, larger than 5. Okay, so now take a look at all these so-called translation from either a term an English word or an English sentence into mathematical statement. Now, by the way, these words, these sentences, that could be in any language. So for me, it could be Chinese, it could be Japanese, it could be English, but whenever we're translated into a mathematical statement, all three language speakers will all understand what it means. All right, so now these examples, just let me quickly take a look, and you should have no problem in pursuing some of the exercise questions here without me showing any example. So number is more than 3. So then the number is more than 3. You write it like that, so that is more than 3. Now, how do you put on the number line? At least 12 years old. A textbook has this kind of example, but before I was taught that you put this dot right on the number line, because here you put it on top of the 2. It's difficult to see whether or not it's exactly 2. So we put it right on the 2, and then we raised it by a bar, and then we use this one to represent that this number is not only 2, but any possibilities on the number line that is larger than 2. All right, now this is the first introduction to inequality. Thank you for watching.